Hi folks, in this video I am gonna solve the problem Leetcode-207 Course Schedule. There are total of num courses you have to take, labeled from 0 to n-1. You are also given an array of prerequisites. Prerequisite is gonna indicate which course depends on which course. For example, the pair 0-1 indicates that in order to take course 0, I have to take course 1. So course 1 is going to be dependent, course 0 is going to be dependent on course 1. Return true if you can finish all the courses, otherwise return false. Now, in order to solve this problem, I need to see if there is any cycle in this graph. For example, in this given 0-1, if I also had 1-0, that means 0 will depend on 1 and 1 also will depend on 0, so I will have a cycle, therefore I will be able to finish the courses. To solve this, I will try to topologically sort given graph, and if I successfully topologically sort it, that means I have no cycle, so I can finish all the courses. Before I jump to the coding, I will explain what topological sorting is. Now, topological sort, when we need to specify the order that some tasks or steps need to be executed in, it is called top sort. It returns a specific order of the vertices of given graph. As you see, like given graph A here, and its topological sorted version is here. But we can topologically sort if our graph is directed acyclic graph. As you see here, like each vertex is directing to another vertex, and there is no cycle here. But before we start to topologically sort, we have to get the in degree values of each vertex. In degree of vertex V is the number of edges which are coming into the vertex V. And I already put the in degree values of each vertex. For vertex 5, its in degree value is 0 because there is no vertex that's coming into V5. For V1 is 1, V2 is 2, as V3 is 1 also, but the in degree of V4 is 2 because V3 and V5 both are coming into V4. And topologically sorting starts with the vertices whose in degree is 0. And in our given graph, I have only one vertex that has in degree of 0. But in some cases, you might have different graphs which has many vertices that have in degree value of 0. So in this case, you can start with whichever vertex that has in degree value of 0. So we could say a graph can have multiple topological sorts. But in our case, we have only one topological sort. Now, how are we going to solve the algorithm? First, we get the in degree value of each vertex, as I showed here. I already prepared those. Then we start with the vertex that has the in degree value of 0. And then I am going to take those vertices out of graph, and as I take them, I will count how many vertices I have removed so far, and also I will update the in degree value of its neighbors. For example, V5 is going to V1 and V4. If I remove V5, that means in degree of V1 and V4 also is going to decrease by 1. So, since we have only one vertex that has in degree value of 0, I will start with V5. So, in degree V5 is our starting point. So, as I remove it, let me update and also I need to, as I remove the V5, I need to I I need to clear those paths, right? Now if I remove, so I also have to update the integer value of v1 to 0 and integer value of v4 to 1. So in this case I have only one vertex that has integer value of 0, so I will clear this from the graph. So then I have to update the integer value of v2. Then I will remove v2. Then I will update v3. And so far I have removed 3, and now I am removing 4th, and then I will remove 5th vertex. So since I removed all of them from the graph, that means I could successfully topologically sort the given graph. So I will say there is no cycle. So in our problem, in course schedule problem, since I don't have cycle, so I will return true. But I want to show one thing. What if I had a cycle here, but the v4 was also directing to v3? In this case v3 would have integer value of 1, and since v3 and v4 both have integer value of 1, and since I have no vertex that has integer value of 0, I wouldn't be able to proceed. So I wouldn't topologically sort this graph. Therefore, as you see, I had a cycle. Now let me jump to the coding. Now before first we have to prepare our integer list and adjacency list. Adjacency list is not specific to topological sorting. It is the way how we are going to represent our given graph to write the neighbors of each vertex. First integer is going to be initially 0 for each course. Times n, and then adjacency list is equal to initially empty array for each course, because I have n courses. Now I will build those arrays for this for in prerequisites. Now imagine I have this prerequisite. That means 1 goes to 0. 1 goes to 0. So I will increase the prerequisites of 0, which is the first element in our prerequisite element, which is the 0th index. So 0th index of integer element will increase by 1. Now adjacency list is preparing is writing down the neighbors of vertex. In our case, vertex 1, its neighbor is 0. So 1 is the second element, which is the first index. So pre1 append pre0. Now I have built integer and adjacency lists. Now I will see which vertices have integer value of 0, and I will keep them in stack. For this, for I in range n, if integer I is equal to 0, stack that append each course. Now I will start to remove, but before I remove I need to initialize the count variable. As I remove, I will update this count variable. So while stack As long as I have watches that has in-degree value of 0, I will keep doing this operation. Current is equal to stack.pop, and since I am removing the current, I will increase this by 1, and now I will see let's say I had this adjacency list. For zeroth element, its neighbors are 1 and 2. For first element, maybe it is 3. So for zeroth element, that means 0 goes to 1, and also 0 goes to 2. So if I remove 0, that means I have to decrease the in-degree value of 1 and 2 by 1. So for this, for neighboring of current vertex, in-degree neighbor minus 1, and I will see if the new in-degree values of for these neighbors 0 or not. If they are 0, I am going to append them to the stack that append neighbor, and if I remove all of them, that means count variable is going to be equal to n, and it should return true. If I am lucky, it will run in the first case. Look like I am not lucky. For in-degree 0, this should be pre-0. This is the confusing part, like that. That's why first thing I look at here. Yes, perfect. As you see, it is like it can be solved intuitively. You don't need to add any other specific logic that you have to memorize. Thank you for watching.